Section 10.7, Interference. So whenever you have multiple waves that come in contact with each other, they can overlap or interact with one another. And when they interact with one another, we call that interference. There are two basic ways that interference can occur. The first is what's known as constructive interference, where you have the crests of two waves that meet together, and so the crests are amplified, and you see that there's an increasing amplitude over time. So this is what you see here on the bottom left. Two waves meet with their crests at the same time, and you get reinforcement. The amplitude of the wave doubles. The other type of interference is what's known as destructive interference, and it's when you have the crest of a wave and the trough of a wave that meet each other at the same time. Here, you have a decrease in amplitude, so when the crest and the trough meet, you get a cancellation, and there's no wave, there's no sound, or no production of a wave after those two waves meet. Any type of interference can occur anywhere in between these two types of extremes. So they don't always have to meet at crest, and trough, or crest and trough. They can meet anywhere in the middle, but they'll add or subtract depending on where they are in their particular wave. So we can use sound interference to accomplish some things. For example, noisy devices like jackhammers are sometimes equipped with microphones that produce wave patterns that are mirror images to the ones that the machine makes, and this causes those sounds to cancel out and essentially make the machine a bit quieter for the person who's using it, not for the people on the outside. You can also use sound interference in speakers by sending out a mono signal and basically align the speakers in such a way that they will cancel out the sound. This is the idea behind noise canceling headphones. When you have sound waves that don't perfectly interfere constructively or destructively, those waves overlap, but not exactly at a crest and a crest, but they get really close, you can get periodic vibrations in the loudness of the sounds. They sound kind of like wah-wahs. And these are called beats. Beats can occur in any type of wave, and they provide some information about interfering frequencies, so which waves are interacting, because we know that they're close. Beats also occur when you are tuning musical instruments. And so if you have any experience with tuning instruments for band or something like that, beats are what occurs when the instruments are not quite in tune but are close. Now, if you produce vibrations on a wave or a string that's somehow fixed with some given length, and you get those waves that you generate on this string to interfere with one another in a particular way, so that they meet at particular points, you can generate what are known as standing waves. And standing waves are waves that move, even with the medium vibrating, but they appear to be standing still. And so what happens is you can generate an incident wave, and if that incident wave and the reflected wave don't meet up, then they can cancel out and you have no wave. Or if they meet up perfectly, you can get this type of wave pattern. Here, the wave that's coming in and the wave that's leaving are overlapping one another. And we have places where the wave or the string doesn't appear to move. These are called nodes. Standing waves are used to operate musical instruments. Standing waves occur on guitar strings, but they also occur with the air inside of wind instruments. Each standing wave is generated on a string or a tube of air of an appropriate length to generate an appropriate frequency that would match the musical tone that it's trying to make.